Hi everyone! So I decided to record a video for your next subtopic. I hope you're ready to learn. So before we start discussing the next subtopic, the new subtopic, so let's do quick recap on the previous topic. Okay? So in the previous topic, you have learned that computer understands the electrical signals of on and off that is represented in binary, okay, right? And also you have learned about decimal and hexadecimal number system. And in tutorial, you have covered the conversion between these three number system, right? Okay, so what question should come in mind after that is how actually does computer use binary to represent data? How is it being arranged? What decides the sequence? Okay, so for that, that's our next subtopic. It is information coding scheme. So, what is coding scheme actually? Coding scheme is actually a combination of zeros and ones that represent character. It can be uppercase letter, lowercase letter, numbers, and special symbols. Okay. Okay, in your syllabus, there are three standard coding schemes that you need to know. The first one is ASCII. It's the American Standard Code for Information Interchange. And the second one is EBCDIC. It Extended Binary Coded Decimal Interchange Code. And lastly, you have Unicode. Among these three, Unicode are the most capable coding scheme that can represent almost all world's language. Okay. Now, let's take a look at this diagram. I'm sure you have seen it before. So what happens when you press T on your keyboard is that electrical signal is sent to the computer circuit, and it is actually converted in the ASCII binary code, which is 010101000 and stored in the memory for processing. So only after processing is this letter then shown as an image on your monitor. Okay. Let's first talk about ASCII. So, ASCII is actually the most widely used coding scheme to represent data. It only uses 8 bits to represent a character, meaning that it can represent up to 256 characters because we just use 0 and 1, right? So you get 256 by calculating 2 to the power of 8. 8 is 8 bits. 2 is 0 and 1 binary, right? So you get 256. So ASCII is mainly used in mini computers, personal computers, and servers. So the advantage of ASCII is it takes less memory to represent data. But the disadvantage is it only sufficient for English and Western European language, but not large enough for Asian and other languages that use different alphabets, such as Korean language, Arabic, or Chinese characters. Okay. Now let's see EBCDIC. So EBCDIC is the properties of EBCDIC is almost similar to ASCII. Number of bits to represent a character is 8 bits, so total number of characters it can represent is 256, but it mainly used in an IBM mainframe, min-range system, and high-end servers. If you don't know what IBM is, you can go and Google. It's a well-known technology company. So again, advantage of EBCDIC is the same to ASCII. It takes up less memory to store data, but unfortunately it cannot represent all the languages in the world, such as Korean language, Arabic and Chinese characters and so on and so on. Okay, now let's see this comparison table between ASCII and ABCD. Although the properties of ASCII and ABCD is similar, but the representation of data is different. So it's the two different coding schemes. As you can see, let's focus on the symbol A. In ASCII, it's represented as 0, 1, 0, 0, 0, 0, 0, 1. In ABCD, it's represented as 1, 1, 0, 0, 0, 0, 0, 1. So it's very different. Okay, now let's take a look at the last coding scheme, which is Unicode. So for Unicode, it's very different from ASCII and ABCD because it's used 16 bits to represent a character. So meaning that it can represent a lot more characters, total of 65,536 characters. You get that by calculating 2 to the power of 16. Okay, so Unicode is mainly used in operating systems like Windows, Mac, and Linux. So the advantage of Unicode is it's capable enough to represent almost all the world's current languages because there's a lot of characters, right? However, the disadvantage is it takes up more memory to store data because it uses 16 bits. Okay, for your better understanding, let's see this table. So we have seen ASCII and ABCD. Now let's focus on Unicode on the rightmost column. So you can see that to represent a character A, it takes a longer sequence of binary numbers because again, Unicode uses 16 bits. Okay, before we end our class, let's see a comparison table between ASCII, ABCD, and Unicode. It's a quick recap of what we have talked about so far. So again, for number of bits, ASCII uses 8 bits to represent a character, the same with ABCD, but for Unicode, it uses 16 bits to represent a character. For the number of characters represented, ASCII and ABCD can represent 256 characters, while Unicode, it can represent 65,536 characters. ASCII is mainly used for mini computers, personal computers, and server. ABCD is mainly used for IBM mainframe, mid-range system, and high-end servers, while Unicode is implemented in operating systems like Windows, Mac, and Linux. So I think that's all for today's class. So thank you to all of you. Thank you for staying focused for the whole video. And any questions, just shout out in the group or DM me personally. So, yeah, that's all.